Welcome all of you for the session 11C, but let us start with the problem definition, solution. So before that, let us recap on what was the problem given. Just a quick recap. You are given a list of function objects rather. Okay, this accepts one parameter, this accepts two parameters, this accepts three parameters. Then this accepts a random number of parameters, random. I have made it 1 to 6, that range. So that means actually I think 1 to 5, I think I have written code. Any number of parameters, either 1 or 5. Now these function objects are kept in a list, which is init list, init function objects list. Now we use this list to generate a random number of function objects, which is picked up from this. Okay, 1 to some number. Okay, it can be anything. This is a configurable number. Your program should be able to configure it. So you will be looking into this list and then fill it up with these function objects in a random order. And then you are also generating another parameter list, which is from 1 to 9, filled it with some random number of values. This is also configurable. These two quantities are configurable. Then what you do is you write another function to go over this list, and if it is expecting one parameter, take one parameter from here. If this expects 5 parameters, take 5 parameters. Like this you go on until this list exhausts or this list exhausts. Any one of them exhaust, you should come out gracefully without any runtime error coming. Okay, that was a problem given, and many of you have already solved it. Now some of you might have tried, given up, or not at all tried. So I am assuming both cases. I have opened an assignment for this, which will have some marks for the evaluation. Those who have submitted already need not have to submit here. This I have given a date of 13th November, which is Saturday night. So you can see my solution. I am not going to share this code as such because you will submit the same code back to me, which I don't want. At least I want you to type it out so that you will understand it. So if I share this code, it will come back to me as a submission here. So I'm not going to share that, but I will show the code implementation here, and you can understand what I have done, and then you do it in your own way, a different way or the same way, no problem. Okay, I don't mind even if you do the same thing, as long as you type it yourself. Okay, that's the plan. Okay, after this this problem we will see. I hope you understand the problem definition. I will not bore you again explaining it. Now these functions, these are the two parameters, which is how many number of function parameters you want to have, function objects, and then how many parameters. Now actually here I have chosen only 2 and 5 function objects are there. That means it is going to run out of parameters. So I wanted each one of you to test it out before submission, but I don't know how many of you have done really. At least I saw one submission without a proper testing. So we can still resubmit it on the assignment entry that I have given. But those who have submitted for bonus, I will try to look at whether it is complete or not. Based on that, I'll give marks. I'll give some partial marks, of course, for trying it out. But of course, the person who does a perfect job. Actually, I saw one solution which is perfectly done, nicely coded. Also, it was perfectly done. So that person will get a full mark, and then relatively others will get a less bonus mark comparatively. Okay, no problem, but I always appreciate you trying it out. Okay, now let us run it first. What will happen is it has only taken, luckily it was 2 function objects with 1 parameter was initially there. So it has taken those numbers 9 and 7 because I have given only 2 parameters in the list, and then it did not have anything for this function, which I have not mentioned the number, I think here. Index 2, it says parameter list exhausted, but I'm not printing the n here. I am not sure whether this version is correct or not. Anyway, no problem. Yeah, so whatever was a function here, it was not able to get the parameter, so it has exhausted and it come out. Okay, it did not go further down to run it because there are no parameters to call them. So implementation is this I will not explain because you already seen these functions. First thing is I asked you to create random number of parameters. So very simple thing is you are passing a list into it, and then you are going to construct the list and pass the same list back out. And number of entries that you want to have are this many number of count. Now what you do, I wanted to say that it is the number between 1 to 9. So I am using the rand range. Range gives you a number in this range. Rand range gives you in the same range 1 to 9, not 10. 10 is exclusive, 1 is inclusive. So 1 to 9, it will pick some number in a random fashion. Okay, that is the rand range. If you say range, you know that it gives in the order. Rand range, it gives you a random number from this every time when you invoke it. So that I am appending it to the list parameter. How many I want? I want this count up to the count. So I am doing a range of 1 to count. Okay. Or I could have done for in that number. Okay. No problem. So I am getting 1, 2, 3, 4, and then I'm just that many times I'm running it and filling the list. Okay. And then they're passing it back. That's all. This is filling a drop of random numbers. Now random parameters. And then random objects. I need to choose from the init list. Actually, this is not needed. Okay, unless you modify it. So I just wanted to put it there so that you get to use that thing, but actually it is not needed in this case. I will explain why, when it is needed and when it is not needed. um, I have mentioned it earlier that whenever you are calling a function, the globals variables are coming it as a dictionary. Okay, it is also a function can access the globals because it is receiving implicitly all the globals in which this function is defined. All variables or function definitions or any labels which are defined in the global namespace, they also get passed to the function. Now you can access them unless you are defining with the same name. Suppose you have a global n, okay, some value equal to 10. This global n, if you redefine it here, okay, with the 2, then it will first look for the label in the local namespace. If you have redefined it, then it will not go look for it. If you have not done it, then if you are using it in your program, then it will check whether it is defined in your global namespace by itself. But if you try to modify it, then you need to have a specifically a statement here. Okay, now for this random object function, it is supposed to use the list which you have made already with the where is it? This list which you have made in the global space needs to be accessed by this function for generating the random number of function objects from this list, right? But it is not writing into this, it is only reading from this list. So it is allowed to even without this it should work. Okay, maybe I will comment off this and then run it. It works. Okay, so I just, if I am modifying it only, it is needed, but I have just put it there. Now what are we doing? We need to now randomly choose one of the objects which is defined there. So how many? That is same, the for loop is there, and then random choice is the function which can be passed a list, and it will pick one entry from this list and give you. Okay, it could be anything, any object, and then that is getting appended to the list. Okay, so how many number of function objects you want randomly fill it, you are doing this here. Okay, that's all. These two are the functions. And then the main thing is here, where it is going to look into this object list, and based on the function it gets it from this list, it is going to access the parameter list, that many number of parameters what is needed before invoking the function. And what it is going to do is it is going to check if this function object what it picks up needs some number of parameters, whether it is sufficient that number of parameters are there in the list or not. It is going to check. If even if it is partially present, it is going to say that I cannot handle it, so it is going to give error and come out. Otherwise it will pick that many number of parameters from the list and then further go forward. Okay, so that is the implementation. Now what we should do, we have to go into the for loop into this object list, pick every object, then check whether that one of this whatever you have picked up, it is anyway guaranteed here that it is one of these functions are going to be found. But here properly, if you are to write, you have to put a else here and then say that error illegal function object received or illegal object received or something like that. You can put it. I have not done that. Okay, it's well defensive programming. It's called defensive programming. But anyway, what we do, we check it whether what function I got. If I got f1, that means it is going to expect only one parameter. So I need to check whether at least what I am looking for is available or not. So what I am doing is I am using this index variable to run through the parameter list. So what I'm doing is initially I'm getting the length of those objects. Okay, actually this is not very much needed. I'm not using it anywhere, I think. I'm not sure, but at least this is needed for me to check that whether I am exhausting the parameter list or not. So I am checking the length and keeping it in a variable. Then what I do, index is starting with a 0. At least there should be one parameter in the thing. That means this should be at least one. This length should be at least one. If I am entering here with a 0 number of parameters, then I can't even execute one function from the list, even if it wants one parameter. So what I do is I do index plus 1 and I greater than. So if this index is 0 to start with, it will be 1 here. It is greater than, this one should be greater than this number. If I have, is it correct I am doing? If this is 1, then yeah, correct. So if I have 0, it is, then I should not go and go up. Is it correct I am doing? Or equal to also should I put? I don't think so. I'm getting confused. Yeah, error condition, right? I'm not looking for a positive condition. Yeah. So at least you should be equal. Okay. Then if it is not, then I am going to give a error. Then I am going to use that index to access the list. Okay, that same index what I am using, I am going to use it to access that one parameter from the parameter list. I am passing it, I am calling the function, that's all. Then I am advancing the index. Then I go through this every time. So if it is 2, I check for 2 plus 2 and then call index plus 1 parameters. Then I am advancing the index. So I think this logic is very simple to follow. Now what about the function n object? Function n object, I told you that when you are generating it, we are making sure that whatever is a random number of parameters passed to this function object should be given as a parameter also. Okay, one more parameter. So what I am doing is I am going to invoke it with a random number of parameters 1 to 5. Okay, that means either one parameter or 5 parameters. That whatever number is chosen, that is going to be the number of parameters I am going to call this function with. Okay, this function object can accept any number of parameter, but I am going to call it some random number of parameters. I am going to pick it from the parameter list, which is less limited to 1 to 5. Anything, it can be anything. I think some of you might have done it in a different way. No problem. Now, after I choose, I want to check whether that many number of parameters are there in the list or not for me to invoke this function, because this function objects can accept any number of parameter. I am choosing 1 to 5 and then checking whether it is sufficient number of parameters are there or not. Then I have to access that many number of parameters from the list, which I am just using a for loop, and I am using a list because append I cannot do, so I am doing a list. You can actually do in a different way. I think one of you have done by using the slicing. That's a very nice way of implementing it. we can slice it and then take out what you want. You don't need to do a for loop, which is not very efficient. Okay, I want you to try out. I did not want to change this implementation. Okay, I wanted to make it a simple for loop, but you can do it using a slicing, which is more efficient. Think about it. No, if you're not done already, you can think about it. Then that many number of parameters are taken from the list. I create a list because I can append it only with the list. Then I convert that list into a tuple because I expect this function object to, because you know that variable number of positional parameters are passed as a tuple. So, and our function object, variable number of function object is, I am taking it as a tuple here. I am not defined it as a variable number of argument. So I am passing it as a tuple there. Okay. And then the number of parameters. Why? Because this function is going to check whether I am invoking it properly or not. This I have put it actually to make you do some work here before calling this, so that this function accepts your parameter. If your input parameter and what you are passing in the tuple are not matching, then it's going to give an error. That you need to take care in your implementation. So that is what you are supposed to do here. What you do, randomly choose some number of parameters and then check whether that many number of parameters are there in the list that you have got. If there are there, then call the function with that many number of parameters. So to create the tuple, I am doing a list first and then converting into a tuple. Then pass the same number of parameter as another parameter here. Okay, this accepts two parameter. One is tuple, and then how many parameters are there in this tuple is passed here, so that that function object can verify it. So that's all. Okay, this is the implementation. So you can check. This will work for any number of thing. Okay, that's it. Unless you have any question, I don't think so. Many of you have done it, and some of you who have not done, please implement it similar way or some better way and submit it before the due date. Okay, so let us go with the problem, or not, the topic of today, decorators. Okay, so what are function decorators? Okay, Python decorator function. Okay, decorator is also a function. A decorator function is a function that adds functionality to another function. So what I mean by that, suppose you have defined a function, okay, something. Some cases I mentioned that inner function, outer function, I explained you. Sometimes you want to package this function into some other function. Okay, this whole thing is packaged into another function. It's like a gift wrap. Okay, wrap. Whatever we normally, even though the gift is small, some people put it in a big cover, big box, so that when the photographer takes a photo in the wedding, it looks like a big box. Okay, and if your friend is very close friend, they will cheat also, that they'll show a big box. Inside that there may be some small chocolate inside or something. So you can cheat somebody with that kind of gift. But don't give me that kind of gifts. Okay, so gift is, the function is here. You put another wrapper around it and call the wrapper. So you pass it back. Okay, you gift it and then pass back the function, and that function is, when you invoke, it will get in. You have to call the wrapper, remove the wrapper, and then that function will also be executed. Okay, so it is similar to wrapping a function with something else. Now when you are wrapping it, you can do some execution, right? You can write some code before and after also. So I'll show you one example. Why am I doing it? Because you don't want to modify the original function, which maybe it is done by somebody else, or it may be a library function also. Even you can take a print function and then modify it to something else. Okay, my print may call another print inside. Okay, so you can put something before and after and then call the function inside. So this is what is called decorator. Now there is no number of wrappers that you can put. There is no limit. You can put boxes over boxes, no problem. they can keep opening it, okay, and then you can reach the function what is there, okay. That is also possible. And then is it required that I should put only one function? No, you can put two functions also. Like in a gift wrapper, you can put two chocolates also inside, right? So you can put two functions also and then wrap it up with the wrapper. So the decorator is nothing but a function which is hiding another function inside or multiple functions inside, okay. And a decorator can be multiple decorators can be there. There are the way it is going to be called, I will show you. So in other words, Python decorators wraps another function without modifying the function. Remember, original gift, whatever you are giving, you are not going to eat the chocolate and then put it inside the box. I expect that the chocolate is intact. So that function is intact, but you are going to put it inside and then call it, okay. So this is a lift like a gift wrapper in real life. This is also called meta programming, okay. Nothing to do with the meta that Facebook has announced. Meta programming is something above, okay, because a part of the program tries to modify another at compile time. So modify or change, okay. During the compile time, this is the function you have written. I am trying to put something around it, and then I am giving that handle to that function, which you can call it. Whenever you call this, it will execute this, and then something if you have put afterward, it will execute, and it will execute the function inside also, okay. So how we are going to put it, I will show you the example. Now this is the example. This is the function you have written, okay. This function, remember, it is getting passed. It is getting passed. Now this is a decorator function, and this is, I will call it, this is an outer function. This is an inner function, okay. This outer function is now getting a parameter which is a function object. We have been playing around with function objects, so now you will be able to easily appreciate function objects, how you can get passed around. Now outer function is given another function object, okay. Here the inner function is calling the function. It doesn't even know what is that function, okay. Don't think that it is getting defined here. It is getting called, okay. It is getting called. What is getting called? What has been passed to the decor function is getting called. We don't know what will be passed during the invocation. Right now we are just saying that whatever I receive, I will call this here. But before calling it, I am going to put some wrapper. This wrapper function itself is something like that. So I am going to print something, okay. This is the wrapper actually I am putting around, okay. The gift is whatever I buy from the shop, I put it inside and then gift wrap it using this, and then I need to pass it back, okay, because I'm going to give it to somebody. So I am passing the wrapper function, this function definition object out. So a decorator takes in a function object and returns another function object. So okay, so decorator takes in a function object and returns another function object. It is like a gift. What you are putting in gift is this, what is coming in, and the wrapper is there, and then the box filled with the gift is a returned function object. So this can be called. When I call this, whatever I have put in will be invoked, okay. So I can have two boxes, gift wrappers, one with a chocolate, another one with some other sweet, maybe jalebi. Now when I give this function object, this chocolate will be there inside. When I give this function object, this jalebi will be there inside. So different function, whatever I have passed, that will get called based on what I am calling. So because it is going to wrap different functions based on the parameter which has been passed. So one thing what you need to remember is this decorator, whatever it is returning, it remembers what object was passed inside, okay, what parameter was given to it. So we have seen some outer inner function with that kind of an example earlier. So that is a precursor for this decorator. So decorator helps us in packaging different things inside. Okay, that's the beauty of the decorator function. Okay, how much time we have? I hope I'm not exceeding the time limit. Okay, 9:30. Fine. Now I hope, let me explain now. This is the outer function which is getting defined here up to this. Okay, this is the inner function. Okay, now you say return. You get a function. Okay, sorry, I think I should not do it like this. Sorry, that's what I was wondering what is happening. This is here, this is here. Okay, so this is the inner function. Maybe tab is not shown properly, and then I am returning a wrap. Now I am not executing it. Okay, no function is getting executed here. Remember that. When I'm putting the chocolate inside the gift wrapper, I'm not eating the chocolate. Okay, I'm not executing the gift. It is just put inside and to be used by the person who is receiving the gift. This chocolate should be eaten by the person who is receiving the gift, not the person who is putting the chocolate inside. Okay, so I am putting the function. I am saying that I'm going to call it inside, and then I'm just sending the wrapper function out. I'm not invoking the wrapper function inside. Okay, it is little different from what we saw in the inner functions. Normally we execute it. Here we are not executing it. We are just receiving the function object, and then I have written a function like this that it puts, I can call any number of time inside, and then I wrap it and then pass the wrapper function out. Okay, so now how is it going to be invoked? When is it going to be invoked? So let me write another function, say hello. Okay, this is a hello function. Now this function is also defined. Okay, it is not invoked, it is defined. You can see that it is only a definition. Function definitions are only, you are saying your function definition, this is also function definition, this is also function definition. Nothing is getting executed till now. Now when I say this, I am calling the decor like this with the input function object, which is nothing but this function object. Now only I am executing this decor. On this side of the fence, I am executing the decor. Now decor is going to receive the hello, say hello function object, and it is going to put the chocolate inside, wrap it up. This function is going to now call say hello. Okay, and then that object is getting passed out. Sorry, it's not dying, but it is getting sent out. Now that is getting assigned here. Okay, still it is not called. This decor is packaged, and then gift is given to it. Now when this gift is opened, that when new function is called, now this is going to be executed by replacing this with a say hello, and you are going to see the wrap function, not this function. Decorer is not going to be invoked, wrap is going to be invoked, and it is going to call this print, this say hello, and this print. Okay, I hope this is clear. The sequence is clear. If once you understand this, the rest of it becomes easier. You can play around with it much easier. So when we call decor with a parameter, the wrap function which was returned by decor, okay, this wrap which is returned by the decor remembers the value of func, okay, value of what parameter is received, which is say hello. Okay, it is as good as filling it up with say hello inside the wrap. Okay, inside the wrap, actually you are doing a grep replace with that function. Okay, it's very interesting feature. Okay, I have not seen this in any other language. I think this is a beautiful feature that Python has introduced. So then this is called a closure. Okay, we have seen the closure parameter property also in Python. Okay, so it is equivalent to the closure. Okay, we are remembering that the function getting, that is what is called the closure property of the function, language. So this is the function decorator. That's all. Okay, nothing else. Okay, let me explain some more detail. Decorators are very powerful and useful tool in Python. It allows programmers to modify the behavior of function. So now how did we modify the behavior? Just a say hello has been beautified with this headers and footer. Okay. Earlier we were just saying hello. Now before saying hello, we are going to maybe like Japanese, we'll bend down and then say properly, and then maybe shake hands. Okay, while saying say hello. So we have added that feature to our simple say hello. We made it beautiful now. Okay. So that we can define decorators with a wrapper that can accept more than one function object as parameter. So you can put more number of chocolates inside, no limit. You can have a, I can say func1, func2, func3 and call each of them inside. And you can play around a lot in this decorator details, okay? More number of parameters. Decorators allow us to wrap another function or functions in order to extend the behavior of wrapped function. So you are actually extending the behavior, okay, beautifying it without permanently modifying it. So you are not actually changing the function as such, but you are adding frills to the around in and around the function. Okay, that's the beauty of decorators. Python's decorators allow to extend and modify the behavior of a callable methods or classes or functions without permanently modifying the callable itself. Callable here is a noun, which is getting called, or the function object which is getting passed. We are not modifying it, but we are beautifying it. Okay. It includes if you want to log some information before calling the function. Maybe if you want to timestamp it. This is a very beautiful way of time stamping your execution time. How much time does it take? Or you want to validate some, suppose you have forgotten to validate some of the parameters while implementing the function, you can do that before. Okay, that kind of added features can be done before you call the function. The usage is very unlimited. Okay, you can imagine a whole lot of things that you can do with the decorators, and you can do different things. Okay, you don't need to do the same thing. If you are decorating a different wrapper, you can put and then perform different things before calling a function. Maybe you want to timestamp it, or measure the performance of a function, how much time does it take, or want to add some printf before it, or maybe call another function before calling this function. Lot many things you can do. Okay, based on your requirement. So enforcing access control, maybe you can even check whether a particular user is allowed to execute the function or not. You can validate it. Authentication you can perform, cyber security or some things, before calling some of your functions, whether the person has got a license to run it or not. Lot many instrumentation, timing function that I mentioned it. Rate limiting, suppose rate limiting means you don't want to call this function with many parameters. Maybe you can limit the number of data or size of the data. Suppose if your function is communicating with the other device. Okay, you are written a function which is sending a packets to another device, and the network it is going over the network, and you don't want to load the network, so you want to rate limit it. You don't want to send all the data. Maybe you can package it, send only a small portion of it, and then once it is successful, you can call another again the same function and send it back across. So rate limiting you can do. Okay, caching I can do. Before calling the function, I can collect the data and then call it function. Okay, caching operation. So many more. Okay, you when you have to do certain things, think about decorators. If suppose the function you don't want to change it, but you want to add something to it, or maybe after the function is called, you want to do some cleanup work or some verification. That also you can do. You can do something before, something after. So the decorator is a very powerful mechanism which you can use it at a different locations or different you can satisfy different requirements. Okay, so function objects accepting parameters can also be decorated. The what I mean by that is, I think which is accepting the parameters can also be decorated means you can call wrapper around wrapper. Okay, multiple decorators can also be applied to a function. So these are the different things that you can do with decorators. Okay, I hope this is clear. I think we have sufficient time to look at the problems, not a problems, some solutions. Let me quickly steal from what I have written. Okay. Um, Inner function. First, just to recap, though we have seen it earlier, what are we doing? This is the outer function. It defines two inner functions, inner one, inner two. It says I am inner one, I am inner two. Here you see that it is not like a decorator. I am calling it inside. I am not just wrapping it. I am putting the, I am not even collecting a function object here. Okay, it is created inside. So don't get confused with this as a decorator. It is a just a, because this concept is extended in a wrapper or a decorator, so I am just showing you. I am calling the inner function. Here what we I told you that inner function is actually visible, or it is namespace is only within the function, but we are extending the availability of this function outside of it. Okay, what is inside we are sure no allowing it to be called from outside. So we are passing it out as a two parameters. So if I call it like this, I am just ignoring the returned objects. Okay, if I am calling it like this, though these returned objects are coming, I am not using it. So it is going to execute this function. It is going to execute once both of them, and then we are not returning it. Now here what I am doing is I am calling this function. That means it is going to execute these two once, and then I am assigning it also. So this inner one and inner two are getting assigned, so I can call it using these objects. Okay, I hope you understand the difference between these two invocation. So let us clear this thing. See here, why is it too many times? These two are because I called this and it got executed by executing the outer, and it also returned the object, but I did not make use of it. I did not copy it. I can ignore it, as I told you many times. Now I am calling again. So these two are again, when I am calling it, again it will get executed. But at this time I am preserving the returned values into these identifiers. Then using the identifier, I'm calling them because these functions don't expect any parameters. So I can call them as it is. Thus, those two are this two. Okay. So I hope you understand this, why you are getting a 6 printouts here. Okay. Now, having understood that, you can understand this code better. Okay, that's why I showed you once, so that you are ready to see a little more complex or what I explained now. Now decorator, this is also an outer function. Okay, this is an inner function. The difference is this inner function is not getting invoked here. Okay, as I told you, you are not eating the gift what we are putting, and it is accepting some gift from outside a function object. Now what I am doing is I am wrapping it. I am calling something before, I am doing something after, and then calling this object which I got. Now I don't even know what it is. So I am just, if I if I get called with a function object, I can execute it. So remember, I need to have a proper function object coming in. Otherwise, it will have a runtime problem. Okay, because if I pass something else which is not a runnable function, callable function, then it is going to have a problem. Well, let us check that also. Before, let us see what is right way of calling it. So it is going to return the wrap. That's all. It is not going to execute anything. It is going to just wrap it up and then call the return the function object. Now decor, I am passing a function object, assigning it to a new function object, and then I am calling it. Okay. Then what will happen? This say hello one will be invoked along with these two things. That means actually it is not calling the say hello one. It is calling the wrap object which came out, which is having a say hello one packed inside. Okay. So this invocation will call this, then say hello function, then this. Okay, so let me say maybe one, this two. Okay, so that we know that they are two different things. Now what about this? I am calling another, defining another function. and then passing it now and calling it. Now these two invocations will have a different things. Now I can call this new func1 and new func again. Okay, maybe I'll type it new func1, new func2. Okay, they will still remember that I was packed inside with the hello one, I was packed inside with the say hello two. Okay, so it's that function object has that information inside. Okay, that's the beauty. Now what if I call just a decor? If I call it, what happens? Suppose if I do that, I'm not I'm ignoring what has come out. Okay, I always told you that return object can be ignored. Even with a decor, if I call it, what will get executed? Okay, nothing will get executed. There is no difference between the previous execution, because I told you that inside the decor we are not eating the gift. Okay, we are just packing it. So it was packed inside but never called, and never, now you cannot even call it because I not even saved the returned object outside. Okay, so now what if I call this decor with maybe some two integer object I am passing? What will happen? It's beautiful. It is not even okay. I am not now. Okay, see this here. It is not giving any error because it is not executing the object. Okay, so it is like a bomb inside. Okay, you have kept a, now if you don't like your friend, you are giving a gift with a bomb inside. When that guy, poor guy, opens it, he is going to face a problem. So let us see. Poor okay, poor person. Okay, I don't want to say guy. Record, I am giving a bad gift, and that person, poor guy, is going to execute it. I hope. What will happen, I don't know. What do you expect to happen? Bomb, boom, bomb inside. Okay, you have kept a bomb inside, which is not an executable function, and you are executing it. Now here I am not executing it, I am just packing it inside. Here and here no problem, because I am just packaging it and then assigning it here. The gift wrapper with the bomb is still there. It's like a suitcase bomb. When I open the suitcase, it's going to explode. That's what has happened. Okay, please don't do that with anybody. uh, okay, okay, I can only comment of this. Fine. Now I am sure you are, oh, I am just running out of time. Okay, let me show you only what is an important thing. Actually, I think this is okay. Now I will show you this. 5 minutes, give me. I will finish it off. It's not going to be very complex. Sorry, I really went into gift mode. Okay, my decorator. I think there is nothing different except that I am assigning the same name here. Okay, don't think that we have already done this tried earlier once. Okay, if you recall in one of the classes, this function object loses its identity as soon as this comes here. Now what happens is, this is a wrapped up function. Okay, I can call this here. No longer this will be called, it is with the decorator only. So I am calling the decorator outer function, I am calling it as a decorator. It is going to be calling always with the decorator now. Okay, now most important thing is to make it easier. Okay, this is what I am supposed to teach you today. How do I make it simple? Okay, I don't want to call this much. Okay, m2 and then this, I am using this with this function. Okay, and then assigning it to the same function name. I can do that by this. Okay, function 3, I am changing the, I am wrapping it up and calling it as a function 3 now. So when you do this at and the decorator, it is say as good as calling a outer function which is name my decorator with the same input and assigning to the same identifier. Okay, here it is equivalent to fn3 getting assigned to my decorator, which is passing, which is getting passed with the function 3. Okay, it is equivalent to this line. We are doing it with one. If you put it above, that means that you are wrapping it up with the decorator function which you have written here. Okay, so I hope this is understandable. In case you have doubt, we can always clear it in the next class. Now, multiple functions, I told you that we can wrap it up. That is the explanation here. I can wrap up multiple function inside. I can put it, and I can call it like this, or I can even call it like a syntax which I have already given you. Okay, I can put a at my multi descriptor. Okay, that also I can do. Now, another common, before I wind up, I can also have any kind of parameter getting passed to a function, which I uh, given you examples. Now, function object, which is can accept any number of parameter. Then wrapper also gets any kind of parameter. So you are now actually packing up with something where you can pass anything to the function object. Don't think that the function object that I am wrapping it up cannot accept any parameter. So that function object can also accept any parameter and many parameters, any number of parameters. That's what is being explained here. Okay, you can see yourself. Then this is okay. This is a good example. Okay, how much time I have? Okay, 5 minutes. Okay, so I have 3 minutes. This is one good example, and I am going to give you one homework also. Okay, I will pick it up to this point and then explain you once for all. Okay. Oh, I missed it. Okay, no problem. Now, one more thing, I am going to leave it with the problem which I want you to try it out. Here, what I am doing is caps decor I am defining, which is caps wrapper, which is whatever string is getting passed, it is returning making it as a caps and then returning it. Okay, this it will convert it into a caps lock, all capital. This one is a split. Whatever string you are passing, it is going to split it into multiple string and pass it. Okay, there is a string split function is going to pass. Now I am going to use it as a decorator. Okay, I can use multiple decorator. I can do multiple wrapping around, and I am going to have a string. Now when I pass this string with multiple wrappers, this is going to be capitalized first and then split. Okay, it is going to go inside out. It is going to be capitalized first and then going to be split up. So if I run it, okay, it is capitalized first and then split into multiple things. Now, whereas if I call the same decorator what I have implemented up, if I reverse this, it is going to give error. Okay, I am not going to tell you what is the issue here. I am sure you all of you are expert programmer now. I want you to change this decorator. Okay, doing the same job. Okay, splitting and then capitalizing it, but I should be allowed to do it in both ways. Okay, split decor or caps decor. Okay, whatever order I do, I'm going to get the same output. After that, I'm going to get a split strings of capital. Homework is, can you rewrite the both the decorators such that it works fine even if the caps decorator and split decorators are interchanged. So let us use the next class beginning to look at the solution which I have written it, and I want you to see if you can do it yourself. I am leaving it as a homework for the weekend.